Okay, class, for today class, we go to the mesh or loop analysis. So mesh analysis provide another general procedure for analyzing circuit. Recall that a loop is a closed path with no node path more than one. Okay, so a mesh is a loop that does not contain any other loop. So remember this one, mesh is a loop that does not contain any other loops, right? So that's mean they are the smallest loops in the circuit. So in mesh analysis, we apply KVL to find unknown currents. Okay, the difference between mesh and nodal analysis. In nodal, we are using Kirchhoff voltage law, right? So to find the uh, node voltage. So in mesh analysis, we are applying KVL, Kirchhoff voltage law, to find unknown current or mesh current. Okay. So next, we go for example straight away, right? For you, to understand what is mesh analysis, because we know that in a mesh analysis we are using Kirchhoff voltage law. So therefore, before we start using that, you need to know how many mesh that we have in that circuit. So referring to the definition over here, mesh is a loop that does not contain any other loop within it. So therefore, for this circuit, okay, we can say that you have three mesh, which is usually your mesh is indicated by the direction of the current, right? So because we are doing a KVL, so therefore we need to note the direction of the current. Okay, usually the best way is actually you find one direction. For we are using the same direction of the current for every mesh. So in this case, I'm using a clockwise direction, so therefore this one I consider I1, and then this one I consider I2, and then this one I consider I3. Okay, please don't use different direction for every mesh, because you will have a difficulty to solve it later. So my advice is really we are using the same direction of the current. So in this case, we are using a clockwise direction for the current. Okay, and then if you already identify the how many mesh in your circuit, and then we already uh, state or choose the direction of the current itself for every mesh. So therefore we can write our KVL equation for every mesh. Okay, so for example, okay, we do the mesh 1 KVL equation. Okay, remember KVL equation is actually the voltage drop around the loop, or every element in the loops actually equal to 0. So therefore, by assigning direction of the current I1 clockwise over here, so therefore the voltage drop across the R1 will be this uh, this using this sign, and then this is the voltage drop across your R2. Okay, it's very important for you to assign uh, the correct sign for every voltage drop around the loop. Okay, so therefore our KVL equation can be write as a negative BB1, right? So plus VR1, okay, which is the voltage drop around at the R1 value, plus VR2 is equal to 0. And then we can say that VR1 plus VR2 is equal to 0. And then one more thing I need to emphasize here, actually, if you see here, okay, at R2 you have two current that flow in your R2. Okay, let's say this is your R2. Okay, the first current that flow in your R2 actually your I1 over here, and then another current is actually your I2 over here. Okay, because we are doing a KVL around mesh 1, so the active mesh is actually your I1, which is the direction of the sign for the voltage drop across your R2. Okay, is due to the I1 direction. So therefore we can say that here your VR2 is actually, we know that V equal to IR, so your R2, okay, I, now you have 2I, so which is I1 minus I2. Okay, so next, okay, we elaborate this equation. So your VR1 is actually IR, which is I is I1, and then R1 plus VR2, we are using this one, which is your I2 minus I1, sorry, I1, okay, I1 minus I2 times your R2 equal to VB1. Okay, sorry again, this is not 0, this is 0. Okay, this is VB1. Okay, so this is our mesh equation for KVL1, and then next we do for the second mesh, mesh 2 KVL. Okay, so now we go to the mesh number 2, which is your I2 over here. So therefore in this case your voltage drop is due to the I2, so this is plus minus, this will be plus minus, this will be plus minus. Okay, now we write our KVL equation, which is VR2 plus VR3 plus VR4 is equal to 0. And then R2, okay, we have two current flowing at your R2. One is I1, another one is I2. So therefore, I2 minus I1 times R2 plus R3, we only have I2, which is I2 R3 plus R4. Okay, you have two current flowing into it, so through it, sorry, so which is I2 minus I3 times R4 equal to 0. So this is another equation, KVL equation. So next we are doing a mesh analysis for mesh 3. We're doing a KVL. So at mesh 3, now we're focusing on mesh 3. Okay, the current flow in your mesh 3 is I3. So therefore, the voltage drop due to the I3 is plus minus plus minus. Right? So therefore, our KVL equation is given by VR4 plus VR5 plus VB2 is equal to 0. And then you can write VR4, actually you have two current, which is I3 minus I2 times R4 plus R5, we only have I3, which is I3 R5 equal to negative VB2. So this is another equation for our mesh, our KVL. All right, so hopefully you can get the concept, which is we are applying KVL equation around the loop. First thing, you need to identify how many mesh do you have in the circuit, and then you need to assign the current direction for every meshes, right? And then next we can write our KVL equation for every mesh. Okay, be careful with the resistor that have more than two current flowing through it. So therefore, for example, you need to look which mesh is active. In this case, for example, in this case we are referring this one, Okay, so this is for mesh 1. You got the sign of R2 due to the I1. All right, so therefore that's why we got I1 minus I2. Okay, so okay, I think that's all for the theory of mesh analysis. We will look more example for mesh analysis. Okay.